All right. For this video, we are looking at finding the mean of a symmetrical distribution. All right. Now, this sounds a lot more fancy than it really is. Okay. If you're talking about a symmetrical distribution, what it means is that you can basically take a line and you can put it down the middle, and it'll give you like two sides that are mirror halves. So if you look at where my cursor is, if I took a line and I put it right down the middle here, right down the middle, right there, it would give me, I'd have these two full x's here, and I'd have these two here, and then I'd have two half x's, because it would go right down the middle, like right where the middle of the x's meet, on 3. And what's nice about those is when you do have symmetrical distributions, in other words, you have the exact same thing on each side of like that middle line of reflection, that middle line of reflection is actually your average. That's your mean. Okay? Now, so looking at it this way, I would say, okay, well, that's easy. My mean would be 3. So let's do this really quick and let's check that. Maybe you call BS on that and you say, well, I don't know if I believe that. Okay, so well, let's test it then. Let's go, all right, fine, let's add all these up and let's divide by 6, because there's 6 pieces of data here. We've got 2 that repeats, we've got 3 that repeats, and we've got 4 that repeats. So we got 2 plus 2, which is 4, plus a 3, which is 7, plus another 3, which is 10, plus 4, which is 14, plus 4, which is 18. So all of these add up to 18. And there's 6 values. 18 divided by 6 is 3. And so when you have a symmetric distribution, you don't have to go through all that trouble. You can just figure out what your middle line of reflection is, or your line of symmetry, is what they call it. And then that's going to be your mean. So for the data set A, it is 3. And for B, it's the same thing. Well, if you look at this, it's a symmetrical distribution, where if you could kind of draw a line right down the middle here between 6 and 7, and you could fold this over and it would be the same thing. That's kind of a definition of symmetry. So what you got to figure out is, well, all right, what's the midpoint between 6 and 7 where you would have that line? Well, you would think it would be 6.5, right? So again, let's test that. Well, we've got 10 here because you've got 2 5s. You've got 3 6s here. Okay, so that's 18. So you got 18 plus 10, you got 28. You've got 3 21s. So 28 plus 21 is 49. And then you've got 16 because you've got 2 8s, right? So you've got 49 and 16. 49 plus 16 is 67? Is that right? 49 plus 16. No, it's 65. And so if you take 65 and you divide 65 by 10, you get 6.5. Right? Because that's that middle point right there. That goes right down there. Okay, so thanks for bearing with me while I was trying to add in my head like that. But 6.5. All right, let's check and see how we did. Look at that. Nice work. Let's do another one real quick. All right, same concept. Okay, so this one right here, you've got 1, 2, 3, 4, 5. Right? So it's kind of like finding median. You find sort of the middle of it, right? And the middle of it's going to go right down the middle of this one right here. So my mean for data set A is going to be 6. All right, and then for B, you've got basically a mirror image of this. If you could split this right in half, right down between 5 and 6. And halfway between 5 and 6 is 5.5. And I'm not going to check these using the other method so that you can see that you can trust this. And you'll see that, yeah, this works. Works really well. So that's one cool thing about data, is that you can find the mean. Remember, the mean is kind of like your average value So if you add everything up, and if you've got it all distributed in a symmetrical fashion, it's going to give you a mean that's right in the middle of it. That's what's kind of cool about means. All right, so good luck with these, and I hope this video is helpful.